We are dealing with chemical reactions every day without noticing it happen. Basically, a chemical reaction is a process in which a substance is converted into one or more new substances. When you eat your breakfast, chemical reactions begin in your mouth as the salivary amylase acts on the food. Then reaction continues in your stomach, where digestive enzymes break down your food into compounds essential for the body, as well as eliminating the waste products. All of these processes undergo chemical reactions. Chemists wants to understand chemical reaction. That's why chemical equation is used to show what happens during a chemical reaction. A chemical equation is represented by this convention. For example, B plus C produces D. The plus sign means B reacts with C, and the arrow means that D is produced from the reaction. The left side of the equation is the reactant side, while the right side is the product side. One good example of a chemical reaction that naturally occurs is the reaction of hydrogen gas and oxygen forming water. This reaction is not balanced. As you can see, there are 2 atoms of oxygen in the reactant side, while only 1 atom in the product side. To obey the law of conservation of mass, there must be the same number of atoms on both sides of the equation. So, we can balance the chemical equation by placing coefficients in front of the compounds or atoms. In this case, all coefficients are equal to 1, but we don't actually place 1. Take note that we are only allowed to change the coefficients, but not the subscripts. The subscripts are the numbers within the formulas. Changing the subscript will change the identity of the compound or substance, thus it will change the equation into different reaction. That's why we only change the coefficients, not the subscript. The first thing to do is look how many atoms of each element are in the reactant and product side. 2 hydrogen atoms are in the reactant side. There are also 2 hydrogen atoms in the product side. There are 2 atoms of oxygen in the reactant side, but only 1 oxygen atom in the product side. So, the next thing to do is to manipulate the coefficient by placing 2 in front of water. Now, there's 2 oxygen atoms on both sides. This time, hydrogen atoms are multiplied by 2, thus equal to 4. We can place 2 in front of hydrogen gas in the reactant side. So, 2 times 2 is 4. There's now 4 atoms of hydrogen in both sides of the equation. Lastly, let's check the balanced equation to be sure that there are same total number of each type of atoms on both sides of the equation. And now, the chemical equation is balanced. Next example. In this chemical equation, each side of the reaction has 1 carbon atom. Also, there are 3 oxygen atoms in the reactant side, but only 2 oxygen atoms in the product side. To balance this, we can manipulate the equation by placing coefficient on the side with lesser number of oxygen atom. Let's put 2 here. Now, there are 4 oxygen atoms in the product side, but there are only 3 in the reactant side. We can place 2 here. The number of oxygen atoms is now equal to 4 on both sides of the equation. Also, number of carbon atoms are equal on both sides, thus the chemical equation is balanced. Next example. Some chemical equation contains polyatomic ions like PO4 in the chemical equation. But PO4 appear in both sides of the equation, so we can treat this as one group. We can see that there's 1 calcium atom in the reactant, but there are 3 in the product. There's 1 PO4 in the reactant, while there are 2 PO4 in the product. There are 2 oxygen atoms in the reactant, while only 1 in the product. There are 5 hydrogen atoms in the reactant, but only 2 hydrogen atoms in the product. To take an action, let's begin by placing 3 here so that calcium atoms in the reactant is equal to the product. We can also place 2 here, so that PO4 in the reactant is equal to the product. Finally, there are now 6 atoms of oxygen in the reactant side, but only 1 in the product side. So we can put 6 in front of water molecule. Let's count hydrogen atoms in both sides of the equation. There are 12 hydrogen atoms in the reactant and product. The chemical equation is now balanced. Thank you for watching this video. I hope you learn how to balance chemical equations. If you want to learn more in chemistry, don't forget to click the subscribe button and the notification bell, so you won't miss anything.